The Milky Way is a tremendous structure in space containing billions of stars and trillions of planets. In their turn, these objects are surrounded by gigantic clouds of interstellar dust and scorching hot gas streams. All these components make up the bizarre and fascinating picture called galaxy. And today, we invite you on an exciting journey across it. For a brief moment, a massive flare will boost its luminosity by a factor of thousands. But within a few months, the star will fade completely, vanishing from the sky forever. Leaving the vicinity of Sirius, permeated by lethal ultraviolet radiation and stellar wind, we will perform a maneuver near the solar system to reach a small star 14 light-years from the Earth. It is designated differently in different catalogues, and one of its names is Wolf 1061. The star is a red dwarf with a radius of about 30% that of the Sun. Its mass is about 4 times smaller than that of our star, and its surface temperature is 3272 Kelvin, or about 3000 degrees Celsius. Like all objects in its class, Wolf 1061 is extremely dim. Its luminosity is only 0.14% that of the Sun, so the star is not visible to the naked eye from Earth. However, this red dwarf has one of the most abundant and diverse planetary environments of any stellar system near us. As many as 3 exoplanets have been discovered in its vicinity, all of them rocky and similar in composition to Earth. But still, conditions on each of the 3 celestial bodies differ considerably. The first and closest exoplanet to the parent star is called Wolf 1061b. It is located 0.038 astronomical units from the center of the system and completes a full orbit around it roughly every 5 days. The object has a mass in the range of 1.5 to 2 Earths and a radius 20% greater than that of our planet. It is likely that the celestial body is tidally locked and faces its star with one side at all times. For this reason, the temperature on the day side of the planet is extremely high, and the flares and stellar winds of the star so close to it virtually rule out any chance of there being an atmosphere. All these factors make the exoplanet completely unsuitable for the genesis and support of life. The second object in the system, Wolf 1061c, is located 0.089 astronomical units from its star and completes a full orbit around it roughly every 18 days. Thus, it is within the habitable zone of the star and can be considered a potentially habitable celestial body. Wolf 1061c is about 3 to 4 times more massive than our planet and belongs to the class of super-Earths. Observations show that its radius is about 1.6 times that of Earth, while the gravity on its surface is calculated to be 60% higher than what we're used to. The exoplanet receives noticeably less energy from its star than the Earth does from the Sun, so its temperature of equilibrium is much lower. It is 223 Kelvin, or about 50 degrees Celsius below zero, which is slightly higher than on Mars. Nevertheless, given variations in temperature during the day and from season to season, liquid water may well exist on the surface of the celestial body. With a dense atmosphere with a pronounced greenhouse effect, this probability is even higher, and conditions on the planet could approach favorable ones. Of all the potentially habitable exoplanets known to date, Wolf 1061c is one of the closest, ranking 5th on the list. The third object in the system is called Wolf 1061d. It follows a clearly elongated orbit, with the distance between the parent star and the aphelium reaching 0.73 astronomical units. As for the perihelion, it lies much closer to the system's center, just 0.21 astronomical units away. It takes the celestial object about 217 Earth days to complete a full year rotation. The mass of Wolf 1061d is calculated to be roughly 7.7 times that of our Earth. If this celestial body turns out to be a rocky object, Its radius is supposed to measure about 1.7 times that of the Earth. If, on the other hand, this planet falls in the category of mini-Neptunes with a thick multi-layer atmosphere, its diameter is supposed to be not less than 2.2 times that of our planet. In spite of a comparatively high eccentricity of its orbit, Wolf 1061d never enters its star's habitable zone. The celestial body is likely to be completely unsuitable for supporting life, but may pose a great scientific interest in terms of planetary evolution. This system is one of top priority destinations for future explorations, and it is highly probable that there are new discoveries to be soon made in it. In addition to everything else, the star Wolf 1061 is also remarkable for its position, which is virtually at the very edge of the so-called local interstellar cloud. It is an area in space filled with hot but extremely rarefied hydrogen. Its temperature measures about 7,000 Kelvin, and on average there is just 0.3 of an atom to be found in 1 cubic centimeter of space here. It is about twice as little as the average value in the Milky Way. The solar system has been moving through the local cloud for the past 10,000 years. Its average diameter is about 30 light-years, but our system is almost at its very edge. Alpha Centauri, for example, is already in the neighboring so-called G-cloud. We, on the other hand, will spend about another 2,000 years within our cloud, after which we will enter an even thinner and hotter region. The local interstellar cloud was formed by the collision of two giant bubbles of hot cosmic gas. It has a momentum of its own, which is perpendicular to the direction of the solar system's motion, and also has a magnetic field and radiation. Fortunately, despite the high energy of the interstellar gas particles that make up the cloud, there is no threat to organisms on Earth. The solar wind is a reliable protection against cosmic hydrogen, and the Earth's dense atmosphere takes the hit of particles that do break through the heliosphere. Still, traces of the isotope Iron-60, also called interstellar iron, have been found in the ice of Antarctica. It is thought to have arrived to Earth from no other place but the local interstellar cloud. As we continue our journey through space, we will soon get to a rather unusual star called AP Columbae, located 27.4 light-years away from Earth. First and foremost, it draws our attention because it was born just 40 million years ago, when the dinosaurs would have long since died out on our planet. What is even more striking is that its birth took place in a completely different region of the galaxy, 450 light-years from the object's present position. Young stars usually remain close to their stellar nursery for quite a long period of time, up to several 100 million years. If you analyze the movement of AP Columbae, however, you will find that it probably previously belonged to the open cluster IC2391. The cluster has about 30 stars, united by a common origin and direction of movement. But a few million years ago, one of them exploded, shattering the delicate equilibrium of a multitude of cosmic bodies. This catastrophe gave the young star an additional momentum that swiftly expelled it from its birthplace. A very small red dwarf with a mass just 13% that of the Sun, this star emits 4 times more energy than any other known celestial body with the same parameters. In addition, its radius is twice as large as calculated based on the modern stellar structure theory. Strangely enough, another unusual feature of the star has helped to provide answers to these riddles. According to spectral analysis of its radiation, the stellar matter of AP Columbae contains an abnormally large amount of lithium. Normally, this element is found in abundance in protostellar clumps, but it burns out completely after the start of a thermonuclear reaction. This means that the star is very young and at the very beginning of its formation, not even in the main sequence phase yet. As a consequence, AP Columbae is unstable and explosive in nature. It is prone to violent outbursts and stellar matter ejections, during which its luminosity may increase by up to 10 times for a short while. Such events would normally threaten exoplanets nearby, stripping off their atmosphere and sterilizing their surface with ultraviolet radiation. As it is, observations show that there are no large space objects within 4.5 astronomical units of this star. In all likelihood, it is too young for the formation of fully fledged planets. Nevertheless, it is a unique cosmic body, very important, and whenever some of them are solved, they add to our knowledge about the universe around us. Are we to solve all its mysteries someday? Time will show.